Sorry about that. My kids stole my iPad charger, so hopefully I can get through the rest of this video here real quick. So now we've tackled one more of these guys. So we've got this one done. So it looks like we only have two left. So hopefully one of these next two will be those kind of problems. So what's the probability that students get more than 3 correct in this case? So more than 3. So in this case, that's going to look like probability of x greater than 3. So we don't actually want to consider. So we don't want, well, this one is kind of silly because I was thinking there was 5. So this is kind of a dumb question. But we'll still treat it the same way because there's only one thing more than 3, which is 4 in this case. But, oh well. So what's the probability the student gets more than 3 correct? So in this case, it would be dumb to do binomial CDF, but I'm going to do it anyway just because I can. So there's really only one thing bigger than 3 in this case, which would just be P of 4. And we could read this off the chart and get its answer that way, 0.0016. But let's pretend like we didn't know that. And we wanted to do this using binomial CDF. So again, same idea. So in this case, since we want to do more than 3 correct, that means I want to actually eliminate the 0 probability, the 1, the 2, and the 3 in this case. So what I'm going to do is I'm going to run my binomial CDF up to that 3. So it's going to work the same way, kind of each one of these guys. So I'm going to do, again, the 1 minus binomial CDF 4.2. And then again, I want to include 3 in what I'm getting rid of. So if I do this right, it should just give us this one single probability, and it should be 0.0016. So let's check the calculator and just verify that that is true. So again, I'm going to hit second enter. Just change this 1 to a 3. And then hit enter, and lo and behold, there we go, 0.0016. So this would have obviously been more effective if we'd had, if there would have been a lot more numbers above 3. But it still lets you know that you can use this binomial PDF, CDF, and things like that to answer these types of questions. It's just you have to think about the way the inequality works, use the fact that probabilities add up to 1, and do some subtracting to make sure we get these guys right. So this one might be like, even before you dive in and start some of these practice ones on your own, you might want to ignore all the answers and try to redo this problem first, just to make sure you got the hang of it, because I've kind of gone through one of every single possibility that could occur and just getting used to the wordings and things like that. So let's do the last one, which should be the very last one up here on our list, the one that's kind of bound in between two numbers in this case. So what's the probability that the student gets at least 1 correct, but at most 4 correct in this case? So again, this is kind of a not a good one because I thought we were going up to 5. So let me change it to 3 just to make it a little bit better. So if we were to write this one out, so at least 1 means we want to include 1. At most 3 means we want to include 3 in this case. So what we want to do is we're looking at, this is the probability of 1 less than or equal to x less than or equal to 3. So again, if we were just writing this out by hand, we could easily just do P of 1 plus P of 2 plus P of 3. And we could go up to our chart and figure out exactly what our answer is, because we already have 1, 2, and 3 all listed out. But the goal is, let's try to see if we can use binomial CDF to figure out how to actually calculate this. So with this one, we have to use 2 actually different binomial CDF commands in this case, because the goal is we want to add basically everything up to 3, but then what we want to do is we eventually want to eliminate the 0 case. In this case, we want to eliminate, because 0 is the only thing below that needs to be subtracted out. Now, there's another problem. There could be a lot of stuff that we want to subtract out, but right now P of 0 is the only thing that we want to get rid of. So we first kind of set this up like it's a regular old, binom CDF. So in this case, I'm going to do binom CDF 4.2. And since I want to include 3, I go straight up to 3. So in this case, that command is going to actually add P of 0 plus P of 1 plus P of 2 plus P of 3. So that's going to give us almost what we want. The only problem is we've got this one extra one. And it's possible if the numbers were bigger, we'd even have more extra ones than that in this case. But for right now, what we want to do is we need to subtract off just P of 0 in this case. So what I'm going to do is another binom CDF. And so again, 4.2. And in this case, so remember, CDF is always a less than or equal to type thing. So I want to include 1. So I end up actually putting 0 there. So I put the highest thing that I want to subtract off. And if there were more things, if there happened to be like P of -1 and P of -2, not that any of those things could exist, like these would all get subtracted too, is the idea. So anything to the left of this would get subtracted. It's just kind of weird because in our case, binom CDF of 0 is just going to capture one thing. But anyway, let's go test this out. Let's type it in the calculator. So let me hit second enter again. Go back and get rid of this 1 minus. Delete, delete. So in this case, we've got our binom CDF up to 3. And then now we want to subtract off the bottom stuff. So we're going to do second vars binom CDF. So again, 4, comma, 0.2, comma. In this case, we want to get rid of anything 0 and below, but there's nothing below 0. So we're really just going to get rid of 0. And in this case, we get 0.5888. So let's go back and write this down somewhere. So 0.5888. And just to verify, let's write down P of 1, P of 2, and P of 3 and make sure we get the same thing. So P of 1 was 0.4096. 0.1536. And 0.0256. Got 18, 10, 13, 18, 8. And lo and behold, same thing. So that means we didn't mess it up, which is good. But trust me, this is where this can get tricky, trying to figure out, well, am I using binom CDF? Am I using 1 minus binom CDF? Do I include the value? Do I not include the value? So kind of doing what I did, if that helps, like writing things out, I encourage you to do that just to kind of help you think about it. So I have made a little summary here just to kind of let you know what I went through. So in this case, if we're trying to find the probability of a number exactly, then, like if this number, let's just for sake of argument, let's just put a 5 in there for all these just for practice purposes. Then binom PDF would just be NP5. If we were doing less than or equal to, then again, binom CDF works exactly perfectly. So we just enter the exact same number. If I'm doing a strictly less than though, so in that case, I need to use that number minus 1. So in this case, that would actually be a 4 because again, I don't want to include, so if this were 5, less than 5, then I want to just go up to 4 in that case. If I'm doing a greater than or equal to, then again, this means I need to spin everything around and use the 1 minus. So in this case, I would do 1 minus binom CDF 4. If I was doing x greater than the number, then in this case, if this were 5, then I would actually 1 minus binom CDF 5. Let's see, is that what I did? Let's check. Oh, yeah, I did use the number. So good. I was making sure I was following my own rules here. And then finally, here's the weird A-B situation one. And so what we did is binom of B, just straight up to B, but then we had to do A minus 1, which is what I did on ours, because our A was 1, and so I used 0. in that case. So again, you might want to actually go through and try this example all on your own just to kind of get comfortable with using all the different variations of binomial, PDF, CDF, 1 minus, all the inequalities and stuff like that. And then when you feel pretty comfortable with it and you feel like you've got it down, and again, you can use this summary as a hint. Then I've got a couple practice problems for you guys to work on. So we've got practice 1, practice 2, and then this is a little bit talking about the mean for a binomial random variable. So this is the same thing as actually the expected value that we talked about in the last section. So the expected value or the mean would be the same. And all you do to calculate it is just take the number of trials multiplied by the probability. So like on the problem that we did above, our number of trials was 4. Our probability was 0.20. So if I just do 4 times 0.2, I ended up getting 0.8, which is basically telling me that on average I would expect to get 0.8 of a question correct, which isn't that great. There's not even one question correct, but that's what that's actually telling us in this case. And so there's a couple in here for you guys to practice. So like D, when it says how many of these students would you expect to enroll in college, that's what that's looking for. That's looking for the mean, like what's the mean value that you'd expect to enroll. And then same thing for practice 4, number B, or letter B in this case. So dive in, try those couple practice problems. If you have any questions, I'll be around all day tomorrow. Otherwise, great job. We're done with Unit 1 when you guys have completed this packet. So I look forward to talking to you guys tomorrow. So good luck, and I'll see you later.